Bismillah ar-Rahman ar-Rahim. Wassalatu wassalamu ala nabiyyina Muhammad wa ala alihi wa sahbihi ajma'in. Okay, so today we're going to talk about descriptive statistics with pandas. And we're going to consider this data set and also the weather data set. So this is the grade data set that we have been using so far. It has grades for different type of measures, final exams, projects, and for different genders and different years as well. So what is descriptive statistics? It actually the tools available to summarize and organize the characteristic of a data set. Usually if you have a data set, you would like to have global information about, for example, the average. If I have a data set about grades, I would like to know about the average grades, or if I have a weather data set, the average temperature or the standard deviation, the variation, the distribution of the data set. It's really very important to analyze the data set in advance to get an overall understanding about your data. And this is basically what we do in the beginning of any predictive analytics task. For example, building machine learning models or deep learning models, we need to understand how our data is distributed, because everything that you are going to learn is based on data distribution. It's basically probability distribution of your data that will help you learning some kind of patterns. And this involves, as already mentioned here, the central tendency like the mean, the median, the mode, and also the measure of variability. How spread is your data? If you get an average of 5, you can have all the values equal to 5, or you can have different values, one equal to, I don't know, thousands, and another one minus, but they average to 5. So here in this case, you have different type of data spreading around the mean. And this actually very important to understand. And this can be explained by the standard deviation, by the variance, or by the range of the data, the minimum value and the maximum value. I know that you already know this in statistics, but now you're learning this in the context of data science. Because if you use these tools, it's not just to do statistics for statistics, but to interpret and understand our data. This is why we're actually learning that again into this concept. So the importance of descriptive statistics includes understanding your data. It means quickly grasp the main characteristic of the data set. Also, data quality assessment. Do I have missing values? Do I have a lot of variation? Do I have outliers that I need to take care about them? Okay. And you do a preliminary analysis before going into deep data science project, like foundation for further statistical analysis and hypothesis testing. And also, it can be used for decision making. It informs business strategies and decisions through data insights. And this is pretty much important. When you understand your data, you will be able to take correct decisions. So, first of all, we start by exploring our data. And we do the exploration using the df.head, and this is going to print the 5 first values, so at least you have an understanding about what is your data about, what are the different fields, what are the different columns, okay? You can identify some of the important information or some of the important features, and also you can use df.shape, you know already what is a shape, to sense the scale of your data set, the number of rows, and the number of columns, okay? And you can see here an application, okay? For example, here I have 200 rows and 9 columns. And 200 now, if you are doing predictive analytics, okay, is this a sufficient data set size to go through, or I need to collect more data? So this is how we use our data actually. So usually we investigate about the shape to see the scale of the data, whether it is sufficient or not sufficient to conduct particular type of analysis about the data. And also you can query about the data types. For example, I have different fields. Some are in 24, 64, some are objects, okay? Some are float, and this gives you a better understanding about the different types of your data. So you can actually do this in one command using the df.info, and this is going to return you all the information about your data. Okay, so first of all, the number of columns, the name of each column, or the title of each column, how many values you have in each column. And this is important. Look now, I have 204 values in all columns. What does it mean? I don't have missing values in any of the fields. If you find, for example, I have 200 values here and 195 values here, it means that some of the fields, they have missing values. And now you need to be careful. Okay, what I should do with these missing values? You can identify them, and then you decide to do one of the filtering techniques that we have covered in the previous lectures. Okay, so this is why we do .info. It gives you an understanding about, is there anything wrong with your data? So it can give you whether some values are null or not, because the best data set, you have everything, you have all the data, and all the data is valid. You don't have null values, okay, because the field could be filled in, but it could have a null values instead. And the type of the data as well. and the total memory used by the dataset. For example, this dataset will consume a memory of 14.5 kilobytes. Okay, so it's a small dataset, basically of text. We have also describe. So you have everything in the notebook. You can just try it here. I want you to understand the main concept. So whenever we ask you about a particular type of analytics, you know which method is available and why we're using it. And so the df.describe, it provides a summary that will include the mean, the median, the mode, the standard deviation, the minimum, maximum value, and the quartiles for each and every column, unless you specify which column you would like to describe. But by default, if you apply this on df, it's going to provide you statistics for all of these different values. So for example here, okay, we have the count 204 values. And here we have the mean. This is for the number. For example, the mean is not really necessarily.
Student ID is considered.
Yes, student ID, we don't really need it. You know, this is not a feature by itself. We have here the measure. We have 204 values of the measures. The average measure is the average value of the measure is this one. We have a standard deviation. This is the difference between the different students' values. So we can see in average, there is a spread of the grade between 3. Okay, so 13 is the middle. Okay, so in average, the minimum value is around 13 minus 3.9 is around 10 for the measure 1, or plus 16 in average, of course. This, yes. So this is the standard deviation. It gives me the confidence interval. I am very confident that most of the data is between this interval, 13.8 minus 3.9 and 13.8 plus 3.9. And usually the confidence interval can be at 95%, 90%. Of course, this is just an approximation. The minimum value, the 25% percentile, the 50% percentile, the 70% percentile. Okay, the spread of your data for all your different type of information. Okay. This is just, there is a difference. If you use print, it's going to print it as a text like this. And if you just do it df.describe without print in Colab, it will print it as a table. Just a preference on how you would like to print that. But it's basically the same thing. You can have a custom describe. Okay, so you can specify you want to describe only the numbers or only the objects or everything. So by default, it's everything. And you can see here, I want to describe only the object. So what are the objects that we have here? Gender and term. They are both text objects. So it didn't include any of the numerical values in the describe. So you can make a filter, okay, using include equal objects or mp.number. We have also the size. It gives you the total number of elements, which is the number of rows multiplied by the number of columns, the count and the shape. Okay. So the first type of descriptive statistics is actually the mean, the median, and the or what we call the central tendency. The central tendency. And it's pretty much simple. So if you want to find the mean, you just do df.mean, and this is now applied on the weather data. So sometimes I do examples from the weather data set, and sometimes I do example from the grade data set. So here I take the weather data set, and you can see, for example, df.mean, it will be able to result in the average temperature and the average humidity. And here df.median, it's the median temperature and the median humidity. What's the difference between the mean and the median?
Median is the middle value, like 50% of the...
Yes. So it's the 50% percentile, okay? And the average, yes, is the total average, the sum divided by the total number. And also the mode, the most frequent occurring values. Okay, so here the most frequent values for the temperature is 22, and the most frequent value for the humidity is 55. Okay. So every value gives you a different understanding about the data. And as you become a data scientist, you will have more feelings about the information that is brought by these different metrics. Of course, you can apply the mean to the whole data frame or to a particular columns of the data frame. Like here, we're selecting the column from 3 to 7, which is measure 1, measure 2, project, and final. You have already do slicing. It's like the NumPy slicing. We do the same thing but use iloc to select. Okay, you've done this, I think, in the first notebooks. Okay, this is called slicing. So you can do the slicing from column 3 to 5, 3 to 7. Also the same thing here. You can do dot columns as well. And here you do the slicing only on the columns. So here it means all the rows. Okay, and here it's only the columns from 3 to 7. And it means also the same thing, basically. Or you can specify the requested number, the requested column titles. Okay, here in the data frame. Now the second information is the descriptive statistic, the measure of dispersion, which is the variance and the standard deviation. And as already mentioned in the beginning, it measures the spread of the data around the mean. And it's pretty much similar, so you can use df.var or df.standard deviation to get these values. You can also do slicing if you want to be focused on a particular type of information. Okay. Other metrics that measure the dispersion of data is the range of value, which is the difference between the maximum and the minimum value. It tells you how far these different values. If they are very close, it means that all the values are concentrated around a certain mean. But if they are very far, it could mean that there are outliers or the data is spread, okay, and so on. And we have the interquartile range, the IQR, okay, which is the difference between the 75th percent and the 25th percentiles. What does it mean? This means the concentration of data, okay? The concentration of data, 50% of the data is concentrated between these values and these values. And data outside this range is basically outliers, okay? It's basically outliers. Okay, so we calculate the quantile Q1 at 25% and the Q3 quantile at 75% to make the difference, and this is called the IQR. Yes?
Usually these are measured box and whisker. These are measured in box and whisker.
Yeah, we will come to that, yeah. In box plots. Yeah. But this is just to get the raw values. Okay, to go the raw values, and you can just use the f.quantile, put the different quantiles that you want to have, and will be generated here as a table. Okay, something also very important, the skewness and the kurtosis of the data. Did you hear about this before? The skewness, okay. So the skewness, as already we can understand from the meaning, it means whether the data is deviated. The data distribution, so we have usually distribution of data. It can be normal distribution or linear distribution, but in general it's not normal. It can be skewed to the left or skewed to the right. For example, imagine that I have a distribution of grades, and this distribution of grades is skewed to the right. What does it mean, skewed to the right?
It is better.
Huh?
It is better.
Yeah. What do you infer about the student grades in general?
Skewing,
Negative skewing for the grades. It means most of the student grades are low, are bad. If it is, for example, skewed to the right, it's good. Yeah, left is bad and right is good. We will see this, yes. So basically, we calculate the skewness value, and this is the mathematical expression. We take the average of the sample minus the sample mean. Okay, take all the values minus the mean value divided by sigma square. Sigma is the standard deviation. It's not square. Cube. Yes. Here it's cube and here it's cube. Okay, and this is going to give us if the value is greater than 0, it means we have right skewed distribution. If it is negative, left skewed distribution, and if it is 0, it means it's almost symmetric. Okay, and this is a script that shows how to calculate the skewness on the grade. So it's basically, I would like to check the total grade of the students and dot skew. And if I have this one, what does it mean? It's skewed to the right, yes. Of course, because usually the grade starts from 60 and above. So most of the students are above 60. But if we make the distribution around, for example, C, or, okay, it could be here normal distribution between, let's say, 50 and 100. But if you consider it from 0 to 100, most of the values will be between 50 and 100. You know, it's very low number of students that will have very, very low total grades at the end. Okay. And look, this is now a skewness of minus 0.92. It's negative, so it means
respect to the mean.
Yes, to the mean, yes. So this is skewed to the right.
Yes, because the mean is like, I think 65 or 70.
Yeah, around the mean, yeah.
But if you make the mean, if you change it to the mean.
Yeah, yes, it's true, yes. It's skewed to the left, yes. And here we have high skew, by the way. Now, if you look at this, it has almost skew close to 0. So you can say it's almost uniformly distributed around the mean value.
So the maximum is 1?
Yeah. No, the maximum,
1.0.
so we have 0. No, there is no maximum value. It depends on,
So the maximum skewness which we can get.
Depends on the mean and the
depends on the mean and on the mu and the sigma and on the values. Okay. There is no bound here. Okay.
0 means
Yeah, so this is the skewness of the temperature. Okay, so the temperature is almost uniformly distributed around a certain mean. Okay. So another thing is the kurtosis هو تفرطح يعني how high is the peak? Okay, heavy. Either it has sharp peak or a flat peak. And look, for example, this is a kurtosis 1.5. So here we have almost a sharp peak for the grades. So what does it mean? So the values indicate the distribution with heavy tails and a sharp peak. So this means that such a distribution may imply a higher likelihood of outliers around the total grid. If I have a high peak, it means that I have high concentration of data, but I have also outliers on the left and on the side. Okay, there is a concentration of data in the peak. What does it mean, high peak? It means the frequency, okay, the frequency of the data around the peak.
Okay.
Okay, then I have low frequencies. I have data that are very low frequency. What does it mean, the data that is low frequency? Outliers. Okay, if it is below the 25 percentile, it's outliers, and above the 75 percentile, it's also outlier. So the peak here indicates whether you have consistent data or you have concentration and outliers. Look now, for example, if I apply this to the temperature, okay, here I have 1.5 and here I have minus 0.81. And this means that also the temperature are more uniformly spread around the range. I don't have outliers. There are a little bit of low values, but if you look at from the spread, it's like you have uniformly distributed data, yes. So it gives you different type of insights about the distribution of your data, yes.
If the number is positive, it means it has a high peak, and if the number is negative, it means it has a flatter peak, right?
Yeah, when the value is close to 0, it means it's close to a normal distribution. If the value is high, so whatever it is, negative or positive, it means about the skewness mostly. Okay, but actually the magnitude of the value that will tell us about how flat is the distribution. Okay, that's the meaning. It's how flat, تفرطح. It's how flat. How flat is the distribution?
Minus 0.81 indicates it's right skewed. It's almost left skewed.
Yeah, it's left skewed, as you can see here. But the value, look now, this value is smaller than this one.
Yes.
Okay, and this value is higher. Okay, look now, there is a stronger peak here.
Makes sense.
Okay, heavier peak, sharper peak, yes.
What's the function for total?
Yeah, this one. This is how we calculate it. The mathematical expression is calculated as, so here it's similar, but yeah, it's at the power of 4.
Minus 3.
Yes, and here minus 3, it's because to adjust the formula so that the normal distribution has a kurtosis of 0. So when it is 0, it's almost a normal distribution. So this visually helps to identify whether the kurtosis is close to 0 or not. Yes, that's what does it mean. So it's just for the need of computation to have normal distribution having a kurtosis equal to 0. Okay? And we have also correlation. And correlation, as you already know, it measures the relationship between two variables. For example, here, I would like to measure the correlation between the final exam and the major exam. So I have a correlation of 66%. So how do you calculate the correlation? It's basically we use dfgrade.core. So core, it calculates the correlation. And this is going to return a table like this, providing the values, okay, of the correlation between, for example, here, the major exam and the final exam. And we can also print the correlation as a heat map. This is what we call a heat map. It's like the spread of the heat depending on how strong is the relationship. And you can see a very strong relationship of 1 has a red color, and here it will have blue color for smaller relationship. Of course, we didn't make it between 0 and 1, so this is why it's completely blue, because yeah, this is the scale, but you can play with the scale when you plot the heat map. For example, you can make the scale between 0 and 70, so visually you can have even 3 grade of colors instead of 2, because here I have red, then blue. So here we have kind of moderate coloration. It's not very strong. Usually we say strong coloration, it is above 70%. Look at this one, for example. If we look, this is the correlation between all the different type of exams. So you can see that there is a stronger correlation between measure 1 and measure 2. 73%. I can say usually the students who did well in measure 1 will do also well in measure 2 and vice versa. There is strong correlation, 75, almost 73%. It's less with the project. Okay, but look at the correlation of the project and the final. It's high also. So you know why? Because usually when I used to teach CS102, I made the project related to the final exam. So whoever doesn't do the project will likely not do well in the final exam. So I can understand myself this type of correlation. Yes?
This is real data.
This is real data. This is my data of CS102 that I analyzed over 7 years. So it has a lot of meaning for me. Now I can't tell you why there is a correlation here, because all the projects were related to the final exam. Okay? And you can see also there is a relation between measure 2 and measure 1. I've made also analytics about the impact of the GPA on the grade of CS102 or CS101. This is really important, and we use these kind of tools to even understand the behavior of the students, the behavior of a particular course, grades, different type of information. Yes?
But the correlation, the heat map doesn't really tell you the difference between the correlation and the coincidence. Yani, someone made you banned from the project because he's unattentive in general. And then because he's unattentive in general,
Yeah.
he doesn't do well in time.
The correlation give you general.
Yes.
Yeah, there are outliers, and this is why I have 70%. I don't have 100%. If it is 100%, it should be consistent. But of course, there are some outliers. There are some students that did well in the project, didn't do well in the final exam, and vice versa as well. This impacts about the correlation score. If you have several outliers, that's going to affect the relation between the different scores. Yes?
Considering GPA, CS102 is only like the second semester, so he barely.
Yeah, I found that there is a correlation of around, I don't remember well, but around 70%, it's quite high correlation. Because sometimes we say we have great inflation or deflation. That doesn't really depend from the course or the teacher. It basically depends on the input that I get, and I'm going to teach it. Okay? Of course, there are always variations, but if you find, for example, 90% of correlation, it means you can't do anything, if the level is very... But if you find only 50% correlation, you say, okay, there are some low GPA students that could perform very well in CS101. This can happen because there are students good in programming, but they are not good in other type of courses. Okay? Now, depend on the scores that you get, you can analyze these scores and then understand what's the situation and take preventive actions or corrective actions to improve your course teaching next time. Maybe, for example, if I find that there is strong correlation, I would say I need to change my strategy with weak students to help them, for example, getting better. You see, when you analyze your data later on, you need to take actions based on the feedback that you have obtained from the data. Okay? And this is data science. It's different from statistics. It's not only a pure math or pure calculations, but it's insights. I would like that I teach you insights about how you analyze these kind of values. Now, when you see this plot now, what can you understand from this plot? This is the correlation between temperature, humidity, and window. So don't read this text, but try to focus on this one. Now, I have, for example, minus 60 as correlation score between relative humidity and temperature. What does it mean?
Negative correlation means
Yes, it's inverse. When the humidity increase, the other decrease, and vice versa. And it's kind of moderate correlation, 60%. Okay? So you see how we analyze this. Now I have minus 0.08 between the wind speed and the relative humidity. No correlation. It's completely non-correlation. And if we do a scatter plot, we will find a complete spreading of the data. But if the correlation is high, you will find a good pattern of the data. And this is what helps actually later on to make predictive analytics. It's based on this correlation we can decide whether we can do what kind of predictive models we can analyze. If you have a zero correlation, you can't make the predictions.
Is there like a limit where you choose
Yeah, imagine someone tell you, I want to make a prediction from the wind speed on the relative humidity. And you jump into making predictive analytics, making machine learning models. It's not going to work. You have zero correlation. There is no relation. No, this one doesn't import, the first feature doesn't affect the other. So there is complete non-correlation. This is why we need to do this kind of descriptive statistics to analyze our data. Okay, it's really very important. Where is my stuff? Okay, I think now tomorrow, inshallah, we're going to continue with the visualization, inshallah. Okay. Now you have these slides.
Yes.
Okay. Next week will be all practicing. I will give you 2 days practicing and 2 days exams. And we will finish about pandas. We'll go for statistical learning. We're going to use this tool to go into the first step of machine learning, predictive models. Okay, I want you to understand the relation between the topics because we go gradually. Okay,